you doing with the internet there? Okay. You want to ask William for help?
I guess you got. So you're asking?
Yeah.
Okay. Start letting me. Start showing me the login page. It's like
Which Wi-Fi are you on?
alright. This one, right?
Yeah, that's the one I did. Try going to Google or something in a new tab. Okay, try details. Yeah, it's saying you don't have internet. You're on the Wi-Fi. Okay. You can try Student 5G.
I tried all of them.
Your Wi-Fi worked like on a plane or home or something. Do you have any other web browsers? Try Edge. There you go.
Got it? Got it. I don't know if you use Brightspace. I posted the link there, but you can also just type it in. SciCom.
Yeah, I get it.
You got it? Cool. Alright. So, just a quick tour of the website. I was scheduled for 2-hour blocks. I think there was some things floating around that were going till 6. I don't think we'll need to go till 6. We'll probably do 5. I also have these things. There's 3 applications, 1-hour videos. You can watch these either over lunch or like at night or when you go home or something, right? But I wanted to include them just as a little bit of extra things. So this is the plan for while we're here. This adds up to about 10 hours, and 5 hours of course content, which is 2/3, right? And then the other third is going to be this stuff, which is how to publish your ideas, right? The first homework assignment is due, that says 16 June. Submit problem sets by midnight anywhere on Earth on the following Monday. Okay. Do I have a calendar somewhere? Yeah, here it is. Okay. So, 16 June is this day. So the first homework is due on the 23rd. And then they're due weekly thereafter.
Due on 23rd.
Mm-hmm.
Okay.
So it's assigned on the 16th. And then it's due on the 23rd. I didn't want to assign something on the 9th, because that seemed too soon, like you're just getting home, right? So 16, 23, and the last one's assigned on the 21st of July, which means it's due on the 28th. You're in both classes, so let's look at the other one, just so you can see it. This one's called Crypto. This starts on the 7th of July, so they overlap by a little bit. And this one has weekly assignments as well. These assignments say when they're due. Due 14 July, and then the last one is due, right, Friday, August 8th. Okay? And this one's due Monday, July 28th. Okay? So, this is the other class. You should ask me questions about this while you're here if you have any questions, but I have all of the slides and all of the video. There's videos for lectures, and then there's code for labs. So this is a lab. So you do this lab, and then there's some code that corresponds to the lab, which is varying degrees of detail depending on the type of lab, right? So this lab didn't have a lot in it. You kind of just make a container file. And then some of the labs are more involved. What's a more involved lab? This one was pretty involved. So this has some fairly significant code in it. Right. So those are the 2 classes. You can start on crypto whenever you want. It's available. Okay. This class. Oh my goodness. It's a good sign. It's like 8:30 and my voice is already giving out. Okay.
These slides, the assignment slides is not opening.
On here?
Yes, here.
Yeah, they're not posted yet. I haven't made
They are
them.
not posted yet.
Yeah. Yep. If you want to get started on them, I can try and get the first one up tonight. I have some material I'm going to base it on. Okay. So, the way this works is here. We'll begin with an introduction of what I think scientific computing is. Okay. So, not too long ago, scientific computing meant writing equations in MATLAB. And I think it doesn't mean that anymore. It's become other things. Here's what I thought was important. I looked at a variety of scientific computing courses. First course I ever taught was called Scientific Computing. I taught that class in Python as well. I'm also going to teach a little bit of what I call scientific publishing, which I think is an important part of the computing, right? So we'll get to that. I'm going to teach scientific computing in person because I think that's better to be able to ask questions. The 3 things that were important to me when doing this is that I thought it should be based in Python. which I think is the winning scientific programming language. There's some use of this new language called Julia that's quite popular. I wanted to cover command line tools. My impression is a lot of scientific computing is done like on a cluster computer somewhere, like at a national lab, or maybe it's just on AWS, right? So I thought it was important to make sure you're using command line and you're not clicking things, right? And I wanted it to be fully open source. So one of the real things putting Python ahead of other languages is the real competing language is MATLAB, and MATLAB has a paid license. To me, it's always important for students while they're in a program that I don't give you access to something that has a paid license, and that license goes away when you graduate, because then you can't do the thing anymore. This has been a bigger problem historically than it is now. But there's just so many things around that have a license attached to them. I based this on 2 other classes. The first one is by physicists, and then the second one is by mathematicians. Here is the physics-based scientific computing class, and we do not exactly this stuff. And then sort of this is more how I teach the class, right? And so this is contains a number of things. So I'm not, for example, planning to teach you linear algebra, right? We will touch on ordinary differential equations just a little bit, but we're not going to go into how ordinary differential equations are created, right? And then over here, this is most interesting for its introduction to SciCom I and SciCom I, which are pretty interesting. So you can take a look at those courses if they don't work that well for you, if this course doesn't work that well for you, okay? This is what I would do if I were a student working on this independently. I will make this available to other professors, so Onyinye will have access to this. I decided to teach, or to encourage you to use NeoVim this term. Do you know what Vim or NeoVim is?
No.
Okay. So what I'm going to do is I'm going to open the command line on my computer. You're on Windows, right? So you're going to press the Windows key and type terminal. I don't think you have this installed, but I have something called NeoVim installed, which is a text editor I can use at the command line. And we're going to cover how to actually use it and the benefits of using it later, but I would like you to have access to being able to type and edit files within the command line rather than opening a Visual Studio IDE. Do you use Visual Studio usually? What do you use for your Python?
PyCharm.
Okay, PyCharm, yeah. There's nothing wrong with PyCharm, but I think I should teach you how to use NeoVim. So I'm going to teach you how to use NeoVim, and I'm going to encourage you to use NeoVim this term. Now, there's no way I can tell if you're using NeoVim, right? But I'm going to teach you NeoVim regardless. Okay. Numerical computation is sort of the next thing. We're going to talk a little bit about floating point arithmetic and issues with its accuracy. We're mostly going to talk about that in the context of SciCom I. We're going to look at some high-performance computing techniques, which is mainly going to be vector operations in NumPy, and we're also going to look at the Numba just-in-time compiler for Python, which really improved the performance of my code. And we're going to do some data visualizations in Matplotlib. We're just going to look at Numba. I was looking at using Python, and there is a reference to Fortran. It seemed unreasonable to teach Fortran as well this term. There's nothing wrong or scary with Fortran, but it seems like Numba is just fine for our uses. The real thing that's interesting with all of these tools is sort of the faster you get, the less you get to use pandas, and a lot of people like pandas. And then I would like you to be able to create things that look good, and the ways to do that are Markdown, HTML, LaTeX, Quarto, and maybe Typest and Sphinx. I reserve the right to change those to other things. Typest is kind of the new hotness, and Sphinx is used mostly in computer science, right, for software, so maybe that's not the best fit for us. Now, I'm in slides here. I open these slides, and when I click home, it takes me back to the sort of book web page, which is different from the course web page. So there's SciCom, and there's SciCom QMD, right? So if you need the course schedule, that is living in a different location than the course materials. So you can decide which one of those you want to use. When I was making the course, I found it easier to navigate it this way. So just be aware of those two things. And the way you can get these is you can always just go back and forth through the slides. Okay. So, any questions about anything before we begin?
Not right now.
Cool. We're going to start with Python. You already know Python, so this shouldn't be too bad for you, I think.
Yeah.
Now, for Python, I'm going back and forth between two things here, and I'd like you to see both of them. These are the slides. This is the, book or web page. You can go back and forth between them. This is how you go to the slides. You click on Reveal.js under the table of contents. And then you can get back to the web page by clicking Home and then clicking on the chapter you were in. That's the way I know to go back and forth between them. So you can follow along in either one of these you're interested in. If you don't like either of those things, the next most likely thing for you to like is the markdown file that generated this page, and that's available right here. So this is how you can get access to all your stuff. Okay. Oh, I wonder if my images broke. No, they're fine. Okay. So I'm going to go off the slides, because that's how I'm used to teaching. And you can go off of whatever you like. So let's introduce Python. In the context of a scientific computing course, I think the most important thing with Python is to talk about why we're using Python at all, right? I think that's become easier and easier over time. Python's considerably faster in the last 4 years. No one uses MATLAB anymore. But there are other ways to do scientific computing, right? And so I'm just going to say it's free. It's easy to find, so it's easy to install. It's easy to look up materials for. You can do pretty much everything in it. And there's nothing it can't do. There's things it gets slower at. It is quite a bit slower than Fortran. It's slower than Julia. Even with Numba, it's still supposed to be slower than these other things, but it's fast enough for most applications. I was just talking to William about some of the finance stuff. There's some financial modeling it can't really do. There's some climate modeling it can't really do. That's sort of the limit case for Python. So the case against Python is that Python is also this language that's used for this other thing, which is that it's also used for development, and increasingly it's used for machine learning, data science, right? And so maybe you want a dedicated scientific computing language, right? There isn't really one of those anymore. Now it really is just Python, right? But when I teach Python this term, I'm not going to teach you about classes, for example. Classes are kind of like a software engineering or software development thing. They're not particularly useful. There's cases in which they can be useful in scientific computing, but as a rule, people aren't writing classes, right? They're writing scripts that compute equations, basically. So I'm not going to be creating a server. I'm not going to be managing an SQL database. I think there's a time and a place to use an SQL database in scientific computing, but it's a more advanced topic. Excuse me. Okay. We're mostly going to use 4 Python libraries. And those Python libraries are the traditional scientific computing stack. NumPy is perhaps the most basic and most important of these libraries, and each of these things are a link. So if you want to pop these open, you can take a look at them. So there's, of course, Python. Then there's NumPy. NumPy stands for, or it used to stand for, numerical Python. It might not stand for anything now. And just so you know, I'm not the only person in the world saying this is for scientific computing. NumPy describes itself as the fundamental package for scientific computing with Python. So that's pretty convincing to me. You can even try it right here if you want. Let's see, what would I do? I'm going to import NumPy as NP. Am I? No, I'm not. I can't figure it out in the browser. That's okay. We'll come back to that. Matplotlib is... There was many more ways to plot in Python now than I think there used to be, and I kind of don't really like any of the new ones. The real thing competing with Matplotlib, and I thought about teaching it actually, to me is Seaborn. Seaborn is pretty cool, but it's very stats heavy, and so there's a lot of things that are hard to make with Seaborn in my view. It's also very slow. It takes a long time to load. I found that pretty annoying. You might feel like this visually looks better than that, and in that case you should just learn Seaborn. It's not that hard to learn. If you do decide to learn Seaborn, I'm recommending you learn the objects interface, which personally I can't stand, but a lot of people really like. I was talking to some of my colleagues, they really like it. What you probably haven't seen, even if you have seen NumPy and Matplotlib, is SciPy. SciPy is basically a series of extensions to NumPy. It's a huge library, and it's kind of got this interesting thing, fundamental algorithms. Well, if you go into the documentation, and this is kind of cool, I guess we'll go to the reference guide. We'll just click on something. A lot of these functions or methods inside of SciPy, they actually have like citations in them, right? So maybe like what's in data sets, right? So this is, in the sense of science, is academic peer review, right? They're saying what citations correspond to this part of the SciPy library, right? So this is right on the interface between just doing science and just doing computing, right? And that's kind of cool. I don't know if that's relevant to why we would use it or how we would use it, and we'll see they're using Matplotlib as well. But there's sort of, if there's something NumPy can't do, most likely it can be done by SciPy, and some of the most obvious things are it has a much more complete set of constants with like the speed of light, which is not something you have in NumPy. Let's go back. There we are. Okay. SymPy is really cool. I hadn't used SymPy before. I was aware of it. What SymPy essentially allows you to do is you can compute integrals, derivatives, you can find numerical solutions to systems of equations. You can even do this to things that have no closed form solution, and it can get very, very tight approximations. Equations you write in SymPy can be printed out as C or Fortran code that you can then go and run in C and Fortran without having to know C and Fortran, though you have to know how to run it. You don't have to know how to write it. And so this is a pretty sophisticated library. And you see it can do all of these things. Apparently it has plotting in it, which I didn't know, right? But for us, we're going to be particularly looking at solving equations. We'll touch on a bit of calculus, but it can do these other things as well. All these libraries can do matrices. I didn't do a lot of matrix stuff with you because this isn't a linear algebra class, but if you get into linear algebra class, all of these tools will help you in that. Okay. We're going to use a running example for today, and we'll change. Today it's going to be just a piecewise function with income tax. Tomorrow it's going to be the periodic table of elements, and then on Friday we're going to do two different things because we're doing two different libraries. So I just picked something that a student in a science class asked me for help with. And this, I think, was a physics student who was taking an intro math class, posted this equation in Discord, didn't know how to solve it, was not asking for help with computing, right? But I thought the correct way to solve this problem was to use a computer. Okay. This is the problem. I didn't find this a particularly challenging problem to solve, but the student had a hard time with it. I thought one of the easier ways to explain the solution to this problem was by stepping through it in Python. But just in terms of complexity, this is a relatively complex thing. I would expect certainly a middle schooler would struggle to do this. We have a second degree polynomial and a piecewise function. These ranges are a bit interesting. So if I ask you to compute the value of this at 4, right, you have to know that you're specifically looking at 9. Same thing if you put in 8, right? And then this problem didn't actually ask you to plot this or do anything in particular with it, but it asked you to find f of x at each of the following values. So think about how you would do this. And think about it for 1 minute, and then I'm going to show you how I would do it. Alright, do you have the 5 values yet? What's f of negative 1?
Sorry?
What is f of negative 1?
Half negative.
What is f of negative 1?
70.
Sorry, what is it?
70.
How is it 70?
So if for the negative one, right?
Mm-hmm. Yep, negative 1.
So if x is less than 4.
Mm-hmm. Yep.
Okay.
Okay. X is less than 4.
So then So if the x of f of negative 1, right?
Mm-hmm.
So the first one we have 9x squared
Mm-hmm.
plus 59.
Wait, plus 59?
Yeah, 9x squared plus 59.
Why plus 59?
There is sorry, it's my mistake. Let me do it again.
Okay. Do you understand this notation?
Yes.
Okay.
If you want, you can move further.
No, let's at least get through one of them so you understand how to do it
Okay.
and understand what we're trying to do with the Python. So at least figure out f of negative 1.
negative 1 it will be 14,
Okay, why is it 14?
because if suppose x is equal to minus 1
Okay,
and x is less than 4,
okay,
so if you do the formula f minus 1
okay,
equal to 9 minus 1 whole square
okay,
plus 5.
okay. Sounds good. What about the other values? What is f of 4? And that is correct. I just shouldn't clarify. Yes. But yeah, what is f of 4?
Okay, so if it's 4, minus 2.
Why is it minus 2?
So if the value, if 4 is less than or equal to x and oh no, sorry. Yeah. It will be 2 minus 4, so it will be minus 4 because x is right. Am I right?
Why? Okay, I think you said 2 minus 4 is negative 4, so that was not correct.
No. Yes, 2 minus 4 negative 2.
Okay, why is it negative 2?
That's 2 minus 4
Why are you subtracting 4 from 2?
because there is a formula 2 minus x and now x is minus 4.
There's also a formula for 9x squared plus 5, and there's also a formula for 9. Why did you use the formula 2 minus x?
Because if x is less than 4,
Okay,
but then 4 is not is less than 4, it's equal to, so
okay.
that's the logic happens.
Yeah, so of these three expressions, x is less than 4, 4 is less than or equal to x is less than or equal to 8, and x is greater than 8. Which of the three of these is true for 4? Is this one true?
You're asking which one is true for 4?
Yes. So if I plug x into f of x, then I would plug in 4 for x, right? And so this x would become a 4, 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 and this x would become a 4. So some of these would be true and some of them would be not true, right? Because this is an inequality, right? So if x is 4, is x less than 4 true or false?
Coffee's here.
Oh, coffee. Thank you.
Oh yeah, I forgot I ran out of coffee, so I went home and got some.
Oh, thank you so much.
Coffee's here, machine's here, the same machine. You know how to use the Keurig, right?
Yeah.
So, you got plenty of coffee. Enjoy.
Thank you so much.
This will be true for x greater than 8.
So 4 is greater than 8.
Oh, sorry. No. This one, 4 less than or equal to x less than or equal to
Okay.
8.
So this branch is true for 4. So if I put in f of 4, then I'm looking at this line. Oops, hard to select. Let's see. I'm looking at this line, right? Can I select all the way across? No, I can't. Interesting. Right. So then what is f of 4? Okay, so f of 4 is 4. Why is that?
For f or x?
For f of 4. What is f of 4 if this is f of x? Yes. Why is it 9?
Yeah, only value 9.
Okay. So, when we put in f of negative 1, because x is less than 4, we substituted x in 9x squared plus 5 and got 14, I think, right?
Yes, 14.
For 4, because 4 is greater than or equal to 4 and less than or equal to 8, we substituted x in here, there is no x, so we got 9. What is f of 5? What is the value of this expression for x equals 5? What is it for 8?
9, yes.
And what is it for 11?
For 11.
Yeah.
Minus 9, negative 9.
Why is it negative 9?
Because x is greater than 8.
Okay, x is greater than 8.
2 minus x. Like
So I do
2
2.
minus 11.
Yeah. Very good. So here's how I would have done this. Do I have a terminal window open? I don't. Yeah, okay, here it is. Can I? Ooh, that's small, isn't it? I wonder if I can zoom in. Maybe it'll just be small? Maybe function equals. Okay, I don't know how to make that font bigger. Is that really tiny? Can you see that? Okay, it feels small to me.
I can see that.
Yeah. Odd. Okay. So, when I have a problem like this, I like to solve it using Python. Let's see, how do I get out of here? F11. No! Okay, there we go. Okay, so I open Python, and then I have -1, and so I take x equal to -1, and then I compute 9 times x squared plus 5. And the reason I like to type that stuff is every once in a while, it's a little bit too easy with like 2 minus x to think you're accidentally doing x minus 2 or something, and just like get confused and not read it too closely. The next ones are easy. We have 9, and then we have x equals 11, and then we do 2 minus x, right? This is how I do these things, and this is not quite as simple as it should be because this is an unusually complicated equation, right? We usually get something that just looks like this, and then we can just type in 9x squared and set x equal to some value. So we're going to step through a few different ways to solve this systematically, and then we don't have to spend so long thinking about it, right? So let's work through that now. I want to point out that this is a contrived example, I think. I don't believe this is based on any actual like physical system or something, but piecewise functions are, we call this a piecewise function because there's pieces of it. There's the x less than 4, 4 to 8, and x greater than 8 piece. Piecewise functions are a big deal. And until quite recently, I think the United States was the largest economy in the world, and most of its consumer behavior is driven in response to its taxation policies. Its taxation policies are piecewise functions. They're more sophisticated than that piecewise function, but not by that much. Anyways, here's income tax. I think, what am I? I'm married filing jointly, so I compute how much tax I pay on the first $18,000 of my income at 10%, and then the next, whatever that is, $63,000. That's not right, $53,000 at 15%, and then so on, right? And if you're single, then you have correspondingly lower cutoffs, right? So this is how the government basically encourages people to get married, right? You pay lower tax if you're married and filing jointly. And there's also this head of household and married filing separately, and I don't understand those as well. So we will come back to income tax, but we're going to build up the techniques we need with just the example piecewise function first. So I actually asked you to solve this, right? And I also asked you to think about how you solved it, right? And which is sort of the negation of what about solving this makes it hard. And to me, a lot of the hard things about solving this problem are, when I'm asked to solve a piecewise function at 5 points, I have to do the same thing 5 times. Which means, to me, I think of myself as being 5 times more likely to make a mistake, right? And so, something I always explain to students is it's very easy to add 2 numbers together once. Almost everyone can add 2 numbers together once without making a mistake. Almost no one can add 2 numbers together 1,000,000 times without making a mistake. But it is exactly as easy for a computer to add the 1,000,000th pair of numbers together as the first one. So when you're doing things large numbers of times, it makes sense to use computers to do them, and that's how we do more complicated problems. So here is one of the examples. My preferred way to do calculation as an experienced Python user is writing code. That's interesting, this cut off. I wonder how bad that is. Let's see, Python in action. Well, that's not too bad. Okay. So, here's the mathematical expression. I was expecting this to be on one line. That's what's happening. Okay. Here's the mathematical expression. Here's the Python expression for -1. I wrote times here, so for example, we can set x equal to -1. I can do 9 times x squared, or I can do 9 times x times x. I'm assuming you've used squaring in Python before. Do you know what this is going to be?
6 16.
Yeah, so you're familiar with that. And then it gets harder quite quickly. Do you know what this one is?
9.
Oh, it's 27, because it's 3 cubed, right? Yeah. So that's equal to this, right? So you know exponentiation, which I showed you, but you don't have to use it. You can always just write a series of multiplications, especially if you're only squaring. It's not even less typing, right? Excuse me. So this is one way to do this, but this is still quite manual, right? And in fact, I can type 9 times -1, oops, 9 times -1 times -1 plus 5, and that is correct. I can also type 9 times -1 squared, and that is also correct, right? But that isn't really solving the piecewise problem, right? That's actually just computing what 9 times -1 times -1 plus 5 is. And that's not great, because then as soon as I get to 4, then I'm just doing 9s, right? So we're going to look at better ways to do this. In order to do that, I'm going to take just a brief moment to introduce the arithmetic operations in Python. As a rule, these are the operations you use in Python. I have them on the screen, and I'm going to prove to you that you get the same result in Python by typing them in quickly. Now, if you're following along at home, which you probably are, there's these little copy to clipboard boxes here, right? So I can just copy those over and put them in my terminal. Do you have the ability to open Python in your terminal?
Yeah.
Okay, cool. So you can follow along. Then we can divide 6 by 3 as well. Okay. So I have some slides here on installing Python, which you've already done, right? So I'm going to go forward through this. You said you can use Python in your terminal?
Yes, I have installed.
Okay. Which means that you probably checked this box when you were installing it, which is the kind of only important thing. I'm going to use exclusively the command line for this class. The cryptography class, I also only use the command line for that. So here's how you do this on, you're on Windows, right?
Yes.
Okay. And on Mac, and I'm on Linux, which I don't necessarily expect anyone else to be on, though it is the best operating system for scientific computing. But I can still demonstrate the same way. I type my Windows key or my Searchlight key, I type terminal. You've already seen me do this. I already have the terminal open, right? But we can close this and reopen it so we can see an example.
I have worked there. I have familiar with Linux.
That's good. Terminal. Python. I think on Linux I can type Python or Python 3 on Ubuntu. On Mac OS, I'm pretty sure you have to type Python 3 specifically, and on Windows, yeah, I think, can you type, do you type Python or Python 3?
Python 3.
Okay, very good. This is what it would look like on Mac. None of us are on Mac. I have a picture of it, right? Some of the examples refer to Mac. Here's how it looks on Windows. You may be using PowerShell, you may be using command.exe. They're all the same. Let's step through what we're looking at in the terminal just to make sure we're all on the same page with the terminology. So I have my terminal window open here. So, returning to the terminal, we can type at the prompt. What is the prompt? Well, the prompt for me is this flashing cursor here. It is always the last text on the screen. Usually it's after some line with a prefix. In my case, I have my username, which is Calvin. I have my computer name, which is Calvin Precision 3 whatever, which I'm assuming is the name of this computer. And I have an @ sign. So this is my account on this physical computer. Then I have a colon that demonstrates the end of the computer. I have a little tilde, and that tilde is the name of the folder that I am currently in. And then I have a $, which denotes that that is where I can start typing in the command line. So this is quite similar to Mac. Mac has a $, and a flashing cursor. We can look at an example here. But Mac doesn't additionally have all that stuff before it that shows what your current directory is, okay? Windows is quite similar, but I think instead of a flashing cursor, you just have a flashing line that kind of blinks. And you may or may not have something prefixed with PowerShell. So this is PowerShell space, and then this is the file location. So it doesn't give you your username and the name of the computer and the file location, but it does give you the file location. So you probably have PS for PowerShell. I was in C users Calvin, and then I have a one of these ones. I think that's either a greater than or less than. I don't remember which one. Perfect. The greater than is the prompt with the flashing cursor. So that's sort of what I have. I've made these slides on Windows and I'm presenting them on Ubuntu. I don't have access to a Macintosh computer. So I thought you had to type Python on Windows. I could be wrong. You say you can type Python 3 and good for you. But in any case, I return to the window. I can type either Python or Python 3 as I've shown here. So depending on your system, you'll have to use one of these things. Okay? And that's how I open Python. That's how I run it. This is my preferred way to run Python. I don't use it in VS Code. I don't use it in PyCharm. I don't use it in Jupyter. My next favorite way is actually to use it in Colab, which is a whole other thing. So this is what we'll see. Python 12.5. You can see this one is on Microsoft Windows. And then we can compare that. See, this is from August 6th, 2024. It's almost a year old now, right? And then on this device, I have one from February 1st, 2025. I actually just updated my Python installation last night. And this is Python 12.3, right? This was separately made for Linux instead of for Windows. This says Win32. This says Linux. But the next line is the same no matter what. We can type help, or copyright, or credits, or license. And we can see the full license. Nope, we have to spell license. There's the full license. So here's an entire story about Python, right? Very fun. Okay. Now, after I have invoked Python 3, I notice that the prompt changes, and the prompt changes to having 3 greater thans. And so the terminal will behave differently, while the terminal is running Python than while it is not running Python. And the way to tell if it's in Python or not is with the 3 arrows. The first thing to note is that when I have the $sign or the single arrow on Windows, if I type Python, I get access to the Python interpreter. If I type Python again, that's an error. That doesn't work. And that's because Python is a program I can start in the terminal, but it's not something that I can type into Python itself. So there's different behavior whether I'm in Python or whether I'm in the sort of outer shell, the command line, the terminal. Now, within Python, let's go ahead and restart this. I can type just basic mathematical operations, and they work in the predicted manner. I can do relatively complicated things. So for example, I don't know what 1, 2, 3 to the power of 4, 5, 6 is, but Python can figure that out no problem. I would very likely make a mistake if I tried to calculate that manually, right? And I can also do simple things like seeing if this is greater than or less than 4, 5, 6 to the 1, 2, 3, which offhand, I think that would be hard to figure out. In fact, it is true, right? And it's usually true. Usually you want the larger number to be the power, right? So, for example, 2 to the 4 is bigger than 4 to the 2. No, it's not. Okay, I made that up. Wow, really? Oh, yeah. Because that's the same value. That's why it's not greater than. This is a way to show that 9 times -1 times -1 plus 5 is 14. Then we can also do other things. For example, we checked that -1 is, I think we checked that it was less than 4, right? We saw that that was true. So this is just an example of something basic we can type into the Python interpreter. Okay, so now we're going to begin with evaluating expressions. I have to do a time check. Okay. All right. So here are each of the expressions that I had to evaluate to get the solutions here. You'll see that I got this one incorrect. That's because this is still tedious and annoying, right? So what I was actually supposed to do is I was supposed to do 9 times -1 times -1 plus 5. Then I just get 9, then I get 9, then I get 9, then I get 2 minus 11, right? Oops. And I just typed a little backslash by accident there. So this is still quite tedious and annoying, and as you see, you can still make mistakes, right? So that's not great. So what are we going to do instead? Well, we're going to take a more programmatic approach. We're going to use inequality testing. And so we've introduced less than and greater than, and these things are going to tell us whether something is true or false. So we can test them quite easily. We can see -1 is less than 4, and we can see that 4 is not less than 4. We can see that 4 is less than or equal to 4 is less than or equal to 8, but we need to check how to write less than or equal first. So this symbol I think can be a bit annoying. You might have noticed you don't have a less than or equal key on your keyboard, right? So we have to invent some way to type that into Python. And this is sort of the beginning of the difference between programming languages and just understanding things mathematically, right? If I were just teaching a mathematics class, I would just draw that symbol on the whiteboard and we'd all understand what I mean by it, right? In the context of a scientific computing class, we have to have some way to actually type that in. And so we do so with the less than followed by an equal sign. And we can just look at a few examples. We can see that 3 is less than or equal to 4, 4 is less than or equal to 4, and 5 is not less than or equal to 4. And this is distinct from 3, which is less than 4, 4 is not less than 4, and 5 is not less than 4. So that's the difference. We are allowed to put these things together. We can say 1 less than 2 less than 3 less than 4, and they all have to be true. If any of them are false, then the entire statement returns false. This is pretty useful to us because we had that example where we said 4 less than or equal to x less than or equal to 8. And so we're going to need to use things like this. And this is called operator chaining. I find it extremely sketchy, and I don't teach it in Python classes, right? But I teach it in a scientific computing class because it comes up in scientific computing. So we can chain operations. Something that was non-obvious to me when I first started learning Python, I learned this operator first, less than or equal, and I, for some reason, assumed that the open side of the less than sign was supposed to open a line with the equal sign, so I assumed I should write this to do the negation. That's not true. I always put the inequality sign first, followed by the equality sign. And to me, the way that I understood that and began to think that makes sense is I remembered, well, I say less than or equals, and I say greater than or equals. I always say the equals second. So I say equals second. So it kind of makes sense. And we do have the 2 lines, right? So it does look visibly different than the other symbol. It is always important to differentiate single and double equals, so we're going to take a moment to do that. We have experienced sort of in abstract the notion of true and false. I can in fact type in true, and it's not an error the way typing in Python was. So Python does know what true and false are. It does not know what Python is, right? And one of the ways we can do that is we can see that 1 less than 2 is true, and 1 less than 0 is false, right? So we have an easy way to access true and false at any time. We call these true and false values Booleans. They do exist in mathematics, so usually abstractly, and mostly they come up in the case of the piecewise function, right? So there are these inequalities around. We say, oh, is this less than that or something, right? You've perhaps also seen 2D plots that have greater than or less than sort of shaded in on them, right, as areas. So these ideas exist in mathematics as well. And then besides this notion of Booleans, we also have assignment. Assignment is algebra. It is where we take a symbol and we say this symbol can represent any numerical value. We will tell you what numerical value it represents later, right? Assignment is telling the symbol what the numerical value is. And we can sort of go in either direction in Python, where we can write an expression, then assign a value, or we can assign a value, then write an expression. We can go either way. We're going to explore both of these to sort of motivate getting into Python, okay? So, oftentimes, Python expressions are numerical values. We have 2 plus 2, we have 7. These are numerical values, and sometimes they're not numerical values, sometimes they're false. So, there is nothing about Python that forces you to have a number or forces you to have something other than a number. Oh, my throat hurts. That's unfortunate. Okay. I have to talk for a long time today. So, okay. I think the most useful way to use a Boolean expression is with an if statement. And an if statement is a multiple line expression. So, previously when I was doing things where I was saying like, hey, what is 1, 2, 3 plus 4, 5, 6? I would press enter, press the enter key on my keyboard, and I would get the answer back, which is 5, 7, 9, of course. Not every expression is like that, and the first expression that's not like that we're going to encounter is an if statement. So I'm going to write if, and then I'm going to enter a space, and the space is required here. With 2 plus 2 and 2 plus 2, Python is not opinionated on whether you have to have those spaces or not, and we can combine them in all kinds of ways. I think I can even do this. No, okay, I can't put a space before. With if, we have to do if space, and then we open parentheses. Inside the parentheses, we're going to type something that's going to become true or false. We could put true there, that's fine. And that's allowed, right? We can also put expressions there. So we can say 1 is less than 2. Then we can get our 0 back. I'm also going to introduce these sort of print statements. I want to be able to show something to myself. I want to be able to write myself notes. And the way to do that in Python by convention is you print some value. And this looks quite the same as typing 1, but we're going to use print because it always shows up. And by always, I mean sometimes you don't get to see the 1, but you always get to see the print. So we're going to go ahead and use print in some cases to make sure things come through. Let's look at this example here. We're going to say if 1 is less than or equal to 1, print 2 plus 2, and we will see a 4. We're also going to check if 1 is less than 1, which is not true. Then we're going to print 2 plus 2. And in that case, we do not see the print. We can do this the same way with if 1 less than or equal to 1, 2 plus 2. That's the same. And then we can do if 1, I don't like that space there, if 1 is less than 1. We don't get the 4 back. So what this if statement is doing is it's checking to see if something is true, and then depending on whether that something is true, it is either returning or not returning. We can now basically write out our piecewise function. I can say if x is less than 4, then I have 9 times x squared plus 5. And I can say if, let's see, 4 less than or equal to x less than or equal to 8, and I think this was 9. Oh, and I'm not allowed to do 2 ifs in a row.
Elif.
I have to use an elif, right? But we can at least introduce this thing right here. Currently I'm printing values, and so we can just demonstrate the print, and we can demonstrate the non-print. Yes, and correctly we will need something other than if to solve this current problem we found ourselves in. I was going to introduce else first, and so we'll just take a look at else quickly. If 1 is less than 1, oh, I can just copy this, I don't need to type it. And I'll note here that I have this idea that 1 is less than 1. I can type that out, but I have to put it in quotes. If I type 1 is less than 1, I do get an error. That's not allowed, right? So I can include things in quotes inside my print statements. 1 is not less than 1. And then I can say things to myself, like good morning. And it is a good morning. It's a beautiful day out, I think. It looks beautiful out there. It's hard to tell for sure. Okay. And then if we have 3 things going on, we can have the elif keyword. So it is possible that 1 is less than 1, that 1 is greater than 1, or 1 is equal to 1. And if you don't believe me, I'm going to prove it to you right here. Look at that. Glorious, right? And then this is kind of unpleasant to type, so if I say if 2 is less than 1, right? And I print 2 is less than 1, elif 2 is greater than 1, then I print 2 is greater than 1. And this gets quite tedious quite quickly, and it's very easy to 2 is equal to 1. It's very easy to make mistakes when we're printing things or typing things that many times. So we're going to use some other techniques, and we're going to specifically use assignment to solve this problem. So let's go ahead and use assignment. I'm going to assign variables. And the first thing I'm going to do is I'm going to create a variable named x. I'm going to write an equal sign, and I'm going to assign x equal to 1. Then I'm going to take the following. If x is less than 1, okay? And I can evaluate that. I can see that x is equal to 1. Let's set x equal to 2. I will copy paste the same statement. And that will say x is greater than 1, and I can set equal to -1. And then I can see that x is less than 1. And so by using a variable, I can save myself from having to do a lot of typing. And avoiding a lot of typing is really useful in scientific computing, because we might have very complicated equations that we don't want to have to input into the computer more than once, right? So this is the way to use the equal sign. It is very different. You do not say 2 plus 2 equals 4 in Python. That is a different idea. So we're using the equal sign specifically to assign values to variables. That's all we're using it for, and so I call it assignment or single equals assignment. And I'll try to always refer to this idea as single equals assignment. And then we have, it is called single equals assignment because the alternative is double equals equality. So far I've shown that we can see that 1 is less than 1, 1 is greater than 1, 1 is less than or equal to 1, and 1 is greater than or equal to 1. But we didn't know how to check to see if one was equal to something else, right? So we did that with an else statement, right? We don't have to do that. We can use double equals equality, and we can test that like so. I assign x to be 1. If x is equal to 1, I say x equals 1, and then I can set x to be some other value with single equals assignment, and then I can use double equals equality to check to see if it's equal to something. Oops. Did I actually get that? Yeah, there we go. And we can set x equal to -1, and we can see that that is also not equal to 1, right? So I'm able to use this double equals. And now this is where I can write 2 plus 2 double equals 4 and see that that is in fact true. So the equal sign I grew up with that I was more familiar with first is now double equals, and then sort of the more advanced concept of assigning x or y equal to some value is used for single equals. Now that we've introduced double equals, I feel pretty comfortable introducing exponentiation. And so we will say, hey, if you need to raise x to some value, you do 2 asterisks. You may have an inclination to do the caret value, which is used sometimes. That's just a different expression in Python. So I'm encouraging you to refrain from using that. Something that students don't often realize, and so I'm going to point it out, you may at some point in your life want to compute a square root, and there's often this sense that like, oh, you never taught me how to do a square root. That's not true. Let's take x and we'll set it equal to 25, which is a famous square number. It's quite easy to compute the square root of that by raising it to the 0.5 power. So you definitely do know how to do square root. People are always trying to type in square root or, make, I don't know how you'd make a square root symbol with like this or something, I don't know. So you definitely know square root, and you also know cubed root, because you can raise x to the 1/3 power, right? And perhaps that's a little more fun if we take x equal to 27. I'm using the up arrow to scroll up in the terminal and get things that I typed in previously. You don't have to do that, you can type every time, but I wanted to introduce that as well. So exponentiation is useful, comes in handy a lot. We'll use a certain number of polynomials this term. Okay. And with that, I think we can actually write the whole piecewise expression out. So let's go ahead and we'll take this and we'll copy paste it. We'll set x equal to -1, and then we'll paste. And then we'll set x equals to 4, and then we'll paste. And then we'll set x equal to 5, and then we'll paste. And at some point it will occur to us that there should be a way to do this other than copy pasting several lines of code, right? This might feel tedious. This might feel like the entire point of using the computer was so that we don't have to do the same thing over and over again, and I keep doing the same thing over and over again, right? So let's find a better way to do this. And the better way to do this is with code reuse. This is also called control flow, oftentimes in computer science. I wouldn't call it control flow in scientific computing because you're not really thinking about code as something you're like designing or building, right? You're just trying to solve a mathematical equation. So really you're reusing parts of the mathematical equation. We're used to the idea of reusing parts of the mathematical equation because we've all done this, which is just reusing the multiplication operator. And I would even argue that if I take 6 times 7, really that's just the same thing as typing 6 plus 6 7 times. So there's lots of reuse going on in mathematics already. We're just reusing things more generally. Oh, sounds very exciting out there. I wonder what they're doing. I'm going to close the door because it's annoying me. Oh, you'll get, okay, thank you. I think you might be coming up from Florida or something.
Yeah.
Yeah. How long's that flight?
Oh, 1 hour, 20 minutes.
Okay. I'm very jealous. I was on the plane for like 4.5 hours, and I was
You came from Seattle, right?
at Portland. But yeah, same thing, right? Same distance, right? Because the hypotenuse. It's a long time to sit on an airplane. I always get a middle seat because I won't pay extra for it, which is hilarious because I think like the university's paying for it, right? So it would be like $30 for like $1 million institution. I just like don't like giving the airlines money, and I'm sitting there like, okay, all right, okay. We're going to reduce, reuse, recycle. We're going to be good stewards. We're going to take care of the earth. And we're also going to take care of the code that we have to write, and we're going to take care of ourselves, right? So instead of copy pasting or typing more than once, we're going to avoid making mistakes, and we're going to make our lives easier, and we're going to use the def keyword. And we're going to use the def keyword to define functions. There are other ways to define functions in Python. This is the way we're going to do it. The def keyword, like if, is a multiple line statement, and so when we type def, we're going to have multiple lines. We'll begin with a simple example of doubling something. Doubling is fun because it refers to the classic code reuse example of it. If I'm doubling a number, is it more natural to type x plus x or x times x? I don't know. I don't really have an opinion on that. So we'll double x. And what's going on here? Well, previously we wrote an if statement. And I wrote if space, I opened parentheses, I wrote some expression, I closed the parentheses, and then I wrote a colon. We're writing something pretty similar to that. The difference is when we do def, instead of starting with parentheses, we're going to give the name of something. We're going to give the name of something the same way we're assigning a variable. So a natural thing to do is call that f. For example, f of x. Then we're going to have parens, and inside the parens we're going to put all of sort of the arguments to the function. So if we have a function of 1 dimension, we'll have x in here. If we have a function of 2 dimensions, we'll have perhaps x and y, right? We'll begin with just x, and then I'm going to print x plus x. And I'm doing print to make sure I can see the value. If I double 2, I get a 4. If I double 4, I get an 8. And I think this is one of the cases where it's important to use print, because I think if I do def f of x, and I just say x plus x, I think when I say f of 2, then I don't get anything back. And so this is one of the reasons we used printing, right? So how does this work? This is def plus the name of the function plus a left paren plus the name of a variable that we use inside the function plus a frowny face, right? So it ends with a frowny face. When I define f of x, and perhaps, I'm going to make sure that's lowercase. I'll say that's 2 times x plus 3, right? After I define it, when I type f of x out, have I even defined x? We'll say x equals 7, okay. I refer to that as calling f. Why do I think of it as calling? Well, if I think of f as my friend, I can call them on the phone and they'll help me with something, right? So I take f and I call it. And I do want to point out, to be clear, that this x value here just refers to whatever I give to f when I call it. So if I call it my friend and say, hey, 17, my friend will compute 2 times x plus 3. My friend will not compute whatever the value of x is. So if I set x equal to 1, and then I do f of 7, I'm getting 2 times 7 plus 3. I'm not getting 2 times x plus 3. The value in the parentheses replaces the value of the x. So that x doesn't really mean anything. It's just the name I'm giving to something, right? And that's the def keyword. Now, I've been using print because we introduced print previously, but it's often more natural to use this thing called return. So when I call up my friend on the phone and ask them what 2x plus 3 is, either they can send me a letter that has a printout of 2 times x plus 3, or they can just tell me over the phone, right? And so I think of return as telling me directly what the value of an expression is. And so let's take a look at this. 6 is greater than 5. So we'll say def 6 greater than 5 print is going to equal, we're going to print true. Or we can just print 6 greater than 5, right? Then we can say 6 greater than 5 print, and we can see that that is true. There's something we can't do with that, even though it's printing, which is we can't say if 6 greater than 5 print. And we'll notice I am calling with parentheses, and then I have also placed the parentheses around 6 greater than 5 inside my if statement, right? And we get some very odd behavior, right? I don't think that's what you expected to see. And the reason for that, what's going on, is 6 greater than 5 print is printing the value of 6 greater than 5, which is true, but 6 greater than 5 print does not have the value true. It is only printing true. And we can change that to be different by using the return value. So I'm going to redefine this, or I'm going to define a new one. 6 greater than 5 return. It is going to take no arguments, and we're going to return 6 greater than 5. 6 greater than 5 is true. Then I can say 6 greater than 5 return. And this looks quite similar, right? Like in both cases there's a true there. So it looks identical. But if I do an if statement with 6 greater than 5 return, I get the 1 back. And why is that? Well, nothing is causing this true to be printed. So I don't ever see that true. That true disappears and it gets eaten up by the if. In the same way that I say if true 1, I don't see the true, right? This is the same thing as there being a true there. So if I have a return statement, the value of the return statement replaces the value of the function call. It's the same as saying 6 greater than 5. We'll call this a variable, and we'll say 6 greater than 5, right? And then we can say 6 greater than 5 variable, and we can say if 6 greater than 5 variable 7. All right, so a return value is very similar to single equals assignment. And print is very similar to writing something down on a piece of paper. So they look similar, but they are quite different. I think this slide has an error on it where these say print and these say return, and it should be the other way. So someone will have to fix that someday, and that someone's me. Wonder if I can do that. Let's see. 45. Okay. So let's take an example of our, we're investing. I think a rule of thumb I heard once is that your investments should double in value roughly every 7 years, though I think that might have been while the markets were better than they are now. I believe I wrote the function double, so we'll take our savings, we'll set that equal to 10. I have 10 savings, and if I double my savings, I didn't define double. Really? Oh, I called it F. Okay, so we'll do F of savings. Okay. Oh, it's 23. Oh, wow. Our money's going up even faster than I thought. That's great news. Okay. It's 23. Because, yep. I think we were printing x plus x, right? Okay, so if I double savings, there you go. It's important to note that this being called double isn't actually doing anything. It is completely allowed for me to name these things whatever I want. It's just confusing to do that. F double x, print x plus x. There we go. Okay, so let's take savings equal 10. Let's double savings, and then let's see. Double savings, and then let's see what savings is. Okay, still 10. So this is a little bit goofy, right? And I think, where did I define double? Right, there we go. What we want to do instead is to be able to double savings more than once. Being able to apply these functions more than once is quite useful because we might want to find out how much money we have in 14 years if we're doubling every 7 years. So we're going to change to use a return statement. Okay? So we're going to change this to def double x. We are going to return x plus x, and I think that's fine, right? Okay, so then we're going to double savings. In these slides, you'll notice that I'm writing savings again. Why is that? Well, because I'm also saying savings equals, right? So what we're going to do instead is we're going to say savings equals double of savings. And when that happens, I don't see anything at all. So in order to see the value of savings, I type it in and I can see it again. I can also print savings. Right? And so that's what's going on here, right? Now, you might want to be able to do this extremely cool thing, which is that you can double of savings. And I think savings is currently 20. So if I double that, it's going to be 40, and if I double it again, it's going to be 80. And in fact, it is, right? And so this is very cool. And I think I had f of x. What's x? X is 1. And so I can do f of x, which is not allowed because f of x had a return, or had a print instead of return. So if I define f of x to be return 2 times x plus 3, then I can say f of x and f of x and get 13. Okay? This is very nice for a piecewise function because we can now actually compute the piecewise values after defining the function once. So I'm going to write the piecewise function. I'm going to pop my terminal back up and it's going to cover this up, and I'm going to type it in and see if I get the same values. So let's go ahead and do that. I'm going to have def piece, we'll just call it f of x, that's fine. I'm going to use an if statement. If x is less than 4, I'm going to return 9 times x squared plus 5. If 4 is less than or equal to x is less than or equal to 8, I'm going to return 9, and if I do want to point out I'm indenting here, just so all of these ifs are at the same level. If x is greater than 8, then I'm going to return 2 minus x. F of -1, f of 4, f of 5, f of 8, and f of 11 are all computed correctly. And so that's just a nice, cool thing, and that solves the problem that you spent a while working on, right? This is easier than having to figure these things out ourselves. And I would also argue that it is more clear what this expression is doing. Piecewise notation, I think, is non-obvious to a lot of people because we don't see a lot of things like that. To me, I don't really know. I don't want to complain about how the mathematicians do things, right? But it's odd that you check the value of x after you evaluate the value of an expression, right? That feels a little bit odd. So this if statement makes sense here. Here I use elifs. I didn't have to do that now with return. I can just say if, right? I can also apply f more than once. So that's completely allowed. I think I have to do 3 parens there. So that's a very large number very quickly, right? And that's because -12 is being squared, which is 144, multiplied by 9, which is 1,300 something. Yeah, that's right around 1,300. So that's what's going on there. Okay. So there's our piecewise function. We're now going to introduce iteration, which is our other really strong form of code reuse alongside def. Is that watch in the back? Yeah, the clock's wrong, isn't it? No, it's not. I confused the hour hand and the minute hand, right? It is wrong, right? It's, what time is it? It's 9:56. Okay. Cool. All right, so we'll now do iteration. Okay. I found it very annoying. You'll notice that when I was typing live in class, I named my function f. That's because f is 9 times shorter than piecewise, which meant that I had to write 5 times 9 minus 1, which is 8, which is 40 fewer characters to evaluate all of this, right? Look at all of that typing I saved. Look at all of this piecewise. And you'll see I got the same values, right? 14,999, -9, right? So all good. But there's got to be a better way. And the better way is to note that in the original problem statement I gave us, I said, what is the value of f at all of the locations in this set? And in fact, sets exist in Python the same way they exist in mathematics, and I can show that by typing this in. -1, 4, 5, 8, and 11, right? So there's the set. Something a little bit interesting happened, which is those numbers aren't in the correct, or I guess they're not in an incorrect order. They're not in the order I typed them in, right? And it's also not the case that I can say, we'll call this set S, and we're going to define it as follows. S equals. I also can't just apply f to S. That doesn't work. That doesn't make sense, right? So we need some other way to work with these values. What is a set? A set is an unordered collection of elements. That is the definition of set. Oftentimes in mathematics we use these curly brackets to denote a set of things. Right, so this is the set of 1. This is the set of 1 and 2. And it looks like it puts negative numbers at the end, so I think I can get this out of order by doing that. And so you never know what order the elements of your set are going to be in, and that's not really supposed to bother you. It's sort of more like going to the grocery store and getting a bag of groceries. You don't necessarily care what order things go in or come out of the bag, right? You get a set of groceries, right? So Python can recognize sets. Here's a Python set. In some cases, the order comes back the same. In others, it doesn't, right? I want to introduce the type sort of built-in function. So we've written functions like f of x, but there's also built-in functions like print of x, right? Another built-in function is type. And type tells you what type of thing you have. So I can have an int, which stands for integer, which are the round numbers. I can have a bool, which is short for Boolean. And I can also have, we'll type it in again. Or 1, 2, okay. I can also have a set, right? So these are the different types of things we can have. I've cut a few things off of my screen. Are you on slide 52 right now on Windows?
Yes.
Can you see? Does this screen cut off at the same point for you?
No. It says Boolean.
Okay. So I had students last term reported that things were cut off the bottom of my screen and I couldn't reproduce it. It's Windows versus Linux somehow.
Could be by it. It is
Yeah.
perfect for me.
But you can see it. Okay.
It returns a Boolean.
Is Python on the third line on your screen?
I said what?
This word. Do you have 3 lines?
No, 2 lines.
That's the difference. The fonts are different somehow.
Maybe.
Okay. I'll look into this. Because I think there's another place something was cut off. Right. Cut off here. I suspect answer on line 48.
It's in single line.
Okay. I wrote all of these to be single line, so the font is different, I think. Yeah, here it is again. Okay. Very, very interesting. Okay. So, we're going to write a loop, and we're going to write a loop over a set. And I think I created the set S.
You have to scroll to see the cutoff part.
Yeah. There's no real graceful way to do that. I think I can zoom out as well. So that works, right? But then it's smaller, right?
Yeah.
Okay. Let's see if I do plus, then it's... That's pretty tight. We can do that. Okay. So, with a set, I can do something to each element. Now, I pointed out I can't just say f of s, right? That it would be nice if I could do that, but I can write a for loop. And the way I'm going to do that is I'm going to follow these instructions. Okay, I'm going to type the for keyword. Okay. I'm going to type a name to refer to an element like e or x. Okay. I'm going to call it e for element of the set. I'm going to use the in keyword. Okay, for e in. I'm going to say the setter collection. I called it s. Okay. And then I'm just going to do a colon. And then I think I can do f of e. Oh, okay. And there's all the values, right? Something that might be very, very annoying about all of these values is I don't know which of the output values corresponds to which of the input values because the set isn't in order, right? But I can, in fact, do all of that, and all of that works well, right? Okay, so here's an example. And that's not in order. And I know that's not in order because I know f of -1 is 14. And so for e in -1, 1. Are those going to be the same? Yes, they are, right? Because it's squared. So we'll say -1 and 0. and then 1. If we do f of e, we get sort of this strange ordering back, right? I guess 0 comes before both positive and negative numbers or something, right? It's very odd. And maybe the best way to see this is, oops, it changes up the order, right? We can't rely on the order. And that's okay. We're not supposed to rely on the order. A lot of mathematics relies on sets not being in a particular order. You don't really want to be able to say what the first element of the numbers is, because it's negative infinity, and that's like not a real number, right? So this is a bit odd. The way to solve this problem is by switching from an unordered collection of elements to an ordered collection of elements, and we're just going to do that by introducing lists. Lists are virtually identical to sets, but they have square brackets or boxy brackets, and they're called lists. So let's make a little list. I always want to call my lists L, and I stopped typing in L because students said it looks too much like 1. So this is an L, this is a 1. Okay, those do look the same. So I'm going to call this something else. I'm going to call it X's, because there's more than one X in it. So I'm going to call it X's. And I'm going to call it 1, 2, 3. Okay? And actually, we'll do negative 1, 4, 4, 5, 8, 11. That's fine. Okay? This is going to be a bit different because the order is going to be preserved. And sometimes you want the order preserved and sometimes you don't. But if you do want the order preserved, you have to use a list. We are going to be using lists and things like lists more often this term, because oftentimes in science we care about the order of our experiments were performed in, or the order of elements in the periodic table, or the order of some things in a series, right? Or we care about the order that things happen in time, right? So we're going to say for element in collection do thing, for element in collection for x in x's, I f of x, right? Once again, to reiterate, these names are not tied to each other. I can say for y and x's, f of y. And in fact, if I say for y and x's, f of x, I will get a different x, which I'll get whatever this x is, right? So I have to be careful about how I'm using my names, right? But when I say for x and x's, each x in f of x refers to one of them in x's, right? We can see lists by just taking a look at them, but here's something that I think is really cool. You can print out a list, print x's, and the fact you can print out a list means that you can print out more than one thing, which might be pretty interesting to us. So we can say for x in x's, I'm going to print both x and f of x. And this shows the actual correspondence. So now this is something that I could plot on a chart or something. I could say, negative 1, 14, 4, 9, 4, 5, 9, 8, 9, and then 11, negative 9, for example. Right. So we are going to be covering plotting at some point this term, and sort of this is the basis of plotting. We can take a function and look at it in 2 dimensions. Okay? We can do something pretty interesting with lists, which is we can change some of their values, and we can look at individual numbers of their values. So I have x's here, which is the same as on the slide. If I ask x's for the 0th element of x, and this oftentimes confuses people, I'm going to get the initial element of x. So I'm trying to refrain from saying first here, right? These are sort of like addresses on a street. X's is a street. And so, for example, if you go to a block in some cities, you might say like, oh, this is the 200 block or the 8,000 block, right? The house at 8,000 is the house right on the corner. It is the initial house you see when you get to that block, right? Then when you go to address 8001, you see the next house. When you go to 8002, you see the next house, right? In the case of Python, and unlike in many street addresses, we use every single value as an address. We can also change the values, so I can say x's of 0. I can use single equals assignment, and I can change that to -2. And then when I look at x's, I can see that the house at that address has changed. So this is perhaps giving a house a new coat of paint or something, right? And then I can say for x in x's, print x f of x, close bracket. There you go. And I can see, oh, wow, we're all the way up to 42 on our negative value, right? So this is mostly useful. When is this useful? When you've written a good bit of code and you have to change a little thing about it, right? It might also be the case that you want to say, here's x's. We're going to change x's 0 back to 1. No, it was -1, I think, right? Does that look right? We can also say, I don't know. You can say x's of 4, 3 equals 7. I don't know, right? Like, whatever you want to do with your assignment. We can add lists together. There we go. And I want to point out something here that's a little bit sneaky and kind of maybe a little bit sketchy. You've seen we have x previously. In Python, we're allowed to set x equal to expressions over x itself. So I'm allowed to do this. You can also do that with lists. So I can, for example, set x's equal to x's plus x's, right? And that's going to give me 10 values. That's probably a few more values than I need. I can also set x's equal to -1 plus 4, 5, 6, nope, 4, 5, 8, 11. And that will give me back the x's that I want. You'll notice there I took a slight liberty. I didn't put spaces in here. Those spaces are not required. I try to write them for consistency because I try to write the way Python prints things out, but you're not required to write those spaces. Let's compute a list of the results of our piecewise expression. We're going to do that by we're going to create an empty list. So we're going to have a block with no houses on it. Okay? We're going to call it result. And we can look at result and we can see there's no houses on that block. And now we're going to add houses to that block. So we're going to say for x in x's, result equals result plus. And we could add f of x here, right? But f of x is a number, and result is a list, so we can't add those two things together. So we're going to get an error. And we're going to get an error for the same reason we can't do this. That doesn't really make sense. We can't add a number to a block of houses, right? The only way to do this is we have to actually add more blocks, right? Perhaps more lots that the houses live in or something like that, right? So we're going to say for x in x's, we're going to say result equals result, which is the current block, plus we're going to get a new plot of land, and we're going to put f of x on that plot of land. And this will give us the result vector, or the result list. And so we can see that 14 corresponds to f of -1, 9 corresponds to f of 4. Okay? Does that make sense?
Yes.
Okay. Now it is time for your exercise, which is great because I need a bathroom break, so that's good. This will give you something to do. We are going to recall income tax. Let's just fix our zoom. This is probably small, might be hard to see, not to worry. I'm going to zoom in on a specific one. So this is the tax rate for single people paying income taxes in the United States. The tax rate begins at 10%, and you pay a 10% tax rate from your first $0 up until your $9,275. So you pay, no matter how much money you make, the first $9,275 you make in a year, you pay $927.50 in tax, right? And so here we can figure out how much a single person making $400,000 would pay. You would pay 10% up until $92.75. You would pay 15% from $92.75 to $37,650. So that's $37,650 minus $92.75. Then you pay 25% up to $91,000. Then you pay 28% up to $190,000. Then you pay 33% up to $400,000. Does that make sense to you? Do you see what I'm doing here?
I don't get it.
Okay. Every dollar I make is taxed at a different rate. The first dollar I make is taxed less than the 4,000th dollar. So the first roughly $10,000 I make, I pay 10% in tax on them. But after I've made over this amount of money, my next dollar is taxed at 15%.
Okay.
Right, okay.
So if I make less than 9,275, I pay 10% tax.
Yes.
If I pay more than that, then it will be 15%.
But you don't pay 15% on every dollar you make.
Yeah,
You only-
37,000.
Yeah. Yeah. So someone making $37,650 does not pay. You don't pay that amount. And the reason you don't pay that amount is because you pay 10% on 9,275, and then you pay 15% on the rest, which is 37650 minus 9275. And hopefully when you see me doing this, you see why I type everything into Python instead of doing it mentally. I could never, it would take me so long to figure out what that number is, right? So someone making $40,000, right? So if you're making that much money, oh, that's too much. If someone's making $30,000, right, they're going to pay, we'll say x equals 30,000. They're going to pay 0.1 times 92750 plus 0.15 times x minus 92750, which presumably that's wrong. Oh, yeah, because it's not 92750. It's 9275. There we go. So this is how much tax you would pay on a $30,000 income. Is that right? No, it's not, because there's a zero there. I don't know why I'm typing so many zeros. Okay. There we go. So on a $30,000 income, you pay $4,000 in tax. On a $35,000 income, you pay $4,786.25 in tax. Do you see that? And then on a $5,000 income, you only pay the 10% tax rate, so you only pay $500 in tax. Okay. This is how I calculated this out. Let's actually see what it is. So on a $400,000 income, you pay $1,115 to $529.25 in tax. They probably don't charge you the 25 cents. I'm guessing you can leave that off. I think when I was filling out my taxes this year, there was a bunch of cents, and they were like, cut that out. Like, no one has time to remember that you owe 37 cents. You know. You can also do this with x equals x plus, right? So these are the same values. You can use plus equals, which I haven't shown yet, right? X is 927.5, and we can say x plus equals 7, and that increases x by 7, right? So that's fun. And then your assignment is to write a function, def single tax pay, that given pay, returns the tax cost. I have a solution for you here. So you can look at the solution, it's hidden. And then I have a challenge problem, and then I have a bonus solution. I'm going to let you work on this while I refill my water, make some coffee, and go to the bathroom, and you can do that too. And then we will resume instruction in 11 minutes or something, or you can ask me questions. Does that sound good? Cool.
You mind if I get the coffee?
Oh yeah, go for it. I'm gonna make the corrections to my slides that I saw, and then if you happen to finish with this and want to show me your answer, we can go on then. But take the time you need and work on this. Grab some coffee or get back. how you doing on the exercise? I finished my homework. It's like the third fire truck to go by. Yeah. Got it?
Right.
Let me see.
Okay.
So margin rate is 0.396, which is okay. So in tax, every
Yep.
plus equal every tax is 0.330. We want to find out about 0.35.
Yes.
Okay, 35%. So I calculated. This is my code.
Okay. You missed the 35% bracket from 413350 to 4155050. So in line, between line 2 and line 3. Look up at the exercise example, right? There's 35% tax rate for it. You're off by like $20 or something, right? Because there's this $2,000 window where you pay an extra 2% tax. You see, you have the 33%, 28%, 25%, 15% bucket. But you don't have the 35%. And the reason you need that is because that amount, the income amount, is more than 413350, which means there's a few dollars where you're taxed at 35% before being taxed at 39.6%. Does that make sense?
Yes, alright.
So how would you fix that? Wonder how much it's going to change. I bet it's literally going to change by $20. It's even that. Yeah, it's going to change by $4. So I'm thinking about this way. Line 3. There's a good line. I think you copy pasted that line. That represents the 33% tax bracket, which goes from 190 to 413. That's good. There's an additional tax bracket, the 35% tax bracket, that goes from 415 to 413. So all you have to do is copy that line and change the three values, right? So you take that line. Okay. And then the first value has to be 415050. And then the second value is 413350. And that's because that's the range you're getting taxed at 35% on, right? And the percentage is 35.
affect this one because we are already calculating for here. So
Yeah, but so
It's
tax
more-
should have changed because you're adding something additional to tax, right? So income should have changed
but
because.
but
So right in line 9, set tax equal to like 1 million. Just some huge number or something. Will that change the result?
no.
Should it have?
Should it plus equal to or equal to?
Should be same labels. So that changed. So changing the value of tax should change the value.
So negative. Why it's showing negative?
Shouldn't that be negative? It's pretty weird, right? And so something that's interesting is the marginal tax rate is multiplied by a negative value.
Okay.
So anyways, this is an algebra problem, which is not a scientific computing problem, so I'm not too worried about this. It looks like you professionally wrote some Python to do some numerical computing. Do you want to ask me any questions, or do you want to learn NumPy?
No, we can move forward.
Okay. Cool. Yeah, we'll do some NumPy. I think we should try and end around noon and at least wander over to the cafeteria to see if there's anything there we can eat, which I don't know if there will be. I have one more Cliff Bar.
No, I haven't had the breakfast yet. So.
Okay. Yeah, okay. So we'll get over there at noon, because I know it's open then. I'm not sure it opens before noon. But. You think it's open yet? I don't think it opens for an hour. Let's do NumPy for an hour, and then we can go to the cafeteria. If there's like a vending machine around here where you can find something to eat, you can go grab something if you want. I just don't know where else you'd go.
I don't think you have a vending machine in this.
Okay.
Because
All right. Also, I don't know where the cafeteria is, so we'll have to find it. Okay. All right.
that building over there.
If you know where it is, that works well for me.
When we were last time over there, it was close.
Okay.
You remember that?
That was a long time ago. Yeah, I will follow you, is the plan.
Yeah, I know that.
Okay. Cool. All right. Next up, NeoVim. Okay. What is NeoVim? NeoVim is a way of editing text. So far, we have been typing text directly into Python in the terminal. I should get my original terminal back here. So far, here is how I have been using Python. I've typed in Python, and I've said 1 + 2 + 3, like so, right? And that has been fine and dandy, right? And then I've tried to do really annoying things like saying f of x equals if x less than 4, 9, and it was a little bit too easy to mess this up, right? Something like that. If 4 less than or equal to x, and I'm getting drowsy, I'm like falling asleep, I'm typing too much. So we don't want to do things that way. What we want to do instead is we want to have some way of kind of writing a file, and that file can have our functions in it. So we're going to introduce NeoVim as a way to do that, and we're going to introduce NeoVim specifically because sometimes when we interact with like a scientific computing cluster or something like that, we don't have the ability to necessarily easily hook up our IDE to that remote cluster. I think this is becoming less true over time. It looks like VS Code can connect to just about everything now, but it is always easier to have NeoVim and just use it. So why NeoVim? I got really into Vim in the last year and a half, and something that really strongly pushed me in that direction is I was using Visual Code at the time, which is like PyCharm, but I also write C, so I can't use PyCharm, right? And Copilot got added to everything, and it was really hard to turn off, and it kept suggesting what I thought was pretty bad code, right? And so I spent a while digging through VS Code trying to figure out how to turn off all the AI features, and then after a while I thought, well, why am I fighting with my editor all the time? I don't really like VS Code that much. And it got me thinking that, to me, the fundamental problem with so many of the IDEs, and before PyCharm and VS Code, it was Eclipse. Everyone used Eclipse for Java, right? And I never liked the suggestions in Eclipse either, right? The editors were, sometimes it was nice and sometimes it wasn't, and on balance, was it actually easier, right? The thing that all of these have in common is that someone is trying to make money with their editor. They're trying to, Microsoft Visual Studio Code is trying to get us to use Azure, so it has really good Azure integration, but I don't want to use Azure. PyCharm has a community edition and a premium edition, and they always want me to use the premium edition, right? So all of these code editors I was using, I really just wanted to type text into a file and save it, but someone was trying to make money off of doing that. So what is the benefit of NeoVim? It's free. It's maintained by the community. I can contribute code to it. You can contribute code to it. You can get it anywhere. It runs on every operating system, right? For a while, I think VS Code didn't work on Mac or didn't work on Linux. I think PyCharm works on everything now. There's a bunch of Python IDEs. There's PyCharm, there's Spider, there's Positron, there's a bunch of them, Jupyter, right? NeoVim is highly customizable. I think most of the modern IDEs are highly customizable. NeoVim is customizable with a text file, which is pretty cool. So someone else can send me their NeoVim configuration. Some of my other students keep trying to get me to use their Vim settings, which I haven't fallen for yet, but they keep asking me, right? It's stable. Vim is probably around 40 years old. There's people that learned Vim 40 years ago, and they haven't had to learn new keybinds in 40 years. So that they are very, very fast with Vim. So if you start using Vim, you'll get faster your entire life. If you switch IDEs, so the IDEs might help you speed up, right? But you're only ever going to go as fast as that IDE allows you to go, right? I am probably already more efficient with Vim than I am with VS Code, and I used VS Code for around a year and Vim for around a year probably. And before that I was using Notepad++, and I'm probably still faster with Notepad++ than the other ones. Notepad++ has some multi-cursor settings that didn't make it into the other IDEs that are very fast, and so I use those as well. NeoVim is quite powerful. I'm still learning to use it. It has this thing in it. It has this really nice feature called Visual Block Mode, which I'm just going to touch on here as an extension. I don't expect you to start using Visual Block Mode right away, but I think a reason to start using Vim now is so that someday you can be comfortable enough to use Visual Block Mode, right? Visual Block Mode is my preferred way of using multi-cursor, right? If you want to be convinced by Vim, I was actually thinking about teaching a different IDE this term, and then I watched this video. This video is actually made by someone who works for a company that makes an IDE. This person works for Posit. Posit makes this IDE called Positron, which is a Python IDE. They're trying to get people to use. I haven't tried it. This person works for Posit and is still recommending NeoVim. And there's just 12 minutes of content here. You can watch this. I'm not going to click play on a video while I'm streaming on YouTube because I will instantly get banned. So I'm not going to play this for you. You can check it out on your own time. Alongside the 38-minute other video, this is the hour of video content that I'm recommending for today. So, why not NeoVim? Vim is famously hard to use. Do I really believe that? I think it has like a very, very high barrier to entry, and then it becomes very easy very quickly, right? So I don't actually think it's harder to use than anything else. And I think kind of computers are fundamentally hard to use. So right now, if I take my hands and I start typing on my keyboard, strange and unpredictable things happen when I press buttons, right? Kind of the only time my computer does what I expect it to do is if I find some text box to start typing in, and then I successfully type the stuff I want to type. Vim is actually a lot like that, Vim, NeoVim. Let's see, I can close this. I can close this. Okay. And the real thing that's different is I think Microsoft Word first and then Google Docs now have become so popular that everyone assumes that is the only way to type in a computer, which is that you open something and you see a picture of a piece of paper, and you click on the picture of the piece of paper, and then you start typing, and the keys show up on the picture of the piece of paper. Fundamentally, PyCharm and VS Code and Eclipse kind of work the same way. I open up a program, and it shows me a picture of something, and now it doesn't look like a piece of paper, right? But there's clearly still something in the middle of the screen that I click on, and when I start typing, my code shows up there. And so I gave the examples of Microsoft Word, Google Docs, Notepad. I might even have Notepad on this thing. Here, text editor, right? So here's a text editor. I click, and I start typing, and the keys I type show up on the text editor. And perhaps that feels natural to us. NeoVim is terminal-based. It doesn't have to be. There's something called gvim that has its own window. Some of the benefits and downsides to terminal-based are every computer has a terminal in it, but you might not like the terminal you have. The Macintosh OS default terminal seems very bad to me. Some people like it. You can always install some other sort of terminal emulator. I, on all of my devices, just use the built-in terminal. But some people really like this other terminal. There's one called Kitty is a famous terminal. So some people actually install this and use Kitty, and I guess this, I don't know, that looks impressive in some way, right? And that, hey, that's the Ubuntu logo, I think, isn't it? Yeah. See? Okay. So it's terminal-based, and is terminal-based good or bad? I don't know. My sense from talking to people that use computers is a lot of people want a program or a website or an app, and they don't use the command line that much. I think that's basically a bad thing. The reason that's a bad thing is every couple years, at least in my lifetime, a new version of Windows came out, and everyone forgot how to use computers and productivity. And so the terminal has not changed. The terminal never will change. There's reasons the terminal is the way it is. And so it's fundamentally always going to work. So steep learning curve. What does modal mean? Well, let's get into our running example, and we'll follow through with our running example to talk about how I'm going to use Vim and why I like using Vim. So we're just going to assume we're going to use NeoVim, right? And I am not going to claim I've persuaded you should use NeoVim yet. We're just going to assume it, and then we're going to show how to use it. And then at the end, you will probably go back to using your IDE, but hopefully you'll at least feel bad about it. And then in 5 years, you'll start using Vim, which is what happened to me. When I was in my undergraduate class, they said, we can't make you use, then it was Emacs, because I was in an Emacs school instead of a Vim school. We can't make you use Emacs, but we'd like you to use Emacs. And I said, that's stupid. I'm going to use a what you see is what you get editor. My productivity got worse and worse over time as I did more and more sophisticated tasks. I got better and better at programming, and then suddenly all of a sudden one day I was like, geez, why am I not using Vim? And I just picked it up, right? So perhaps that's what happens to you. Perhaps you will go another way. I'm going to introduce NeoVim modes, motions, and operators. So those are going to be words I use, and those are all different than just typing and the text showing up on the screen. Now, I think you worked on the last exercise, so that's good because we're going to have spoilers because the thing I'm going to work through on is the answer. So here was the exercise. Is to write definition single tax. I saw your bonus problem. I didn't see your single tax problem, but I've done one other thing. I changed the font settings in my browser, so I think everything will fit on one screen now. This font may look ugly to you, but I chose it because it seemed to fit. Okay, so here's what I have. I wrote single tax in 2 different ways. I wrote it with and without a list. I found it quite tedious to write it without a list, so I made a list and then I wrote a for loop. But I would argue that this is maybe more sophisticated than anything you've seen so far. What's going on over here is not too complicated. We take our pay and we start with a tax of 0. And if our pay is above a certain level, we multiply that by the highest tax rate, but only the amount over the certain level by the highest tax rate. And then we set our pay to be the amount of money that is left that has not already had tax paid on it. So if I make $450,000 a year, I pay tax on the first bit here, and then I pay the maximum amount in every tax bracket all the way down. This is actually the exact same code, it's just written in a for loop, where this statement is placed inside the loop, and I am using homes and addresses to refer to how much money is being spent in each tax bracket. Does that make sense to you? Okay. I'm going to verify the correctness of this. The easiest thing to check first is we check $500. This should be $50 because we're going to pay 10% on it. Then if we check $4,000, this was like $130 or something. No, I typed 40. Yeah, and yeah, so that's $115. And then a simple thing to do: single tax on 500,000. No, we'll do 600,000, and then 500,000. So I picked 2 values that are 100,000 apart and are in the top range. So the difference between these things should be 39.6% of the difference, which is $39,600. So that means my top tax rate is working correctly, right? So there's various ways to check these matters. I think I can also, for example, check something in the 28 range. So I can say, we'll take someone at 110 and we'll take someone at 100. These differ by 10,000, and they're either in the 33 or 28% bracket. I don't know. Apparently 28% bracket. Right? So I can check that the differences are correct. Do I think that people that make $100,000 a year pay about $20,000 in taxes? Yeah, that sounds right. So this seems reasonable. Yeah. So here's what I just did. I actually copy-pasted this in, but I could have tried to type this, and that would have been awful. There's no possible way I could have typed this without making a mistake. And by the way, if I make a mistake in this line, then I have to retype the entire thing. Right. Now, with a more mature terminal editor, perhaps with Kitty, you might be able to scroll back up or something. I don't know. I'm not going to assume you have your terminal editor set up so you can do that, right? So this is an objectively terrible way to do things, right? And so what is the objectively good way to do things? Well, I'm going to argue it's with a modal text editor. So we're going to introduce the notion of the .py file. I don't know how familiar you or anyone else is with file extensions. My sense was I started undergrad in 2011, and everyone knew about file extensions because they lived through Microsoft changing the Word file extension from .doc to .docx. And everyone hated this, right? I don't actually even remember why we hated it. I just remember it was a common topic of conversation, right? So everyone was intimately familiar with doc files. About 5 minutes after that happened, everyone started using Google Docs and never used Microsoft Office again, right? Now, in Google Docs, there's not file extensions, right? So abruptly, I became the absolute last generation to ever know what a file extension was, right? This was not great because file extensions matter a lot in computer science, and they didn't matter a lot in any other academic disciplines. So now all of a sudden we're teaching file extensions, right? .py is the file extension for a Python file. It only contains text. It only contains things that I type at the keyboard. It is different in this way from a .png file, which is an image file, which contains all sorts of gunk. And it is different in this way from a PDF file, which contains all sorts of gunk. If you happen to open a docx file in the terminal, you would find out that there's a lot of things other than text in there. People are often surprised by this. They only type in text. But we intuitively understand that when we open a doc file in Microsoft Office, there's going to be some bolds and italics and underlines and headings and hyperlinks, right? So that information has to go somewhere. And where it goes is into making a .docx file contain a lot of things other than just the text you type, right? So our .py file is not going to contain anything other than the text we type. These are going to be small files on your hard drive compared to how big a PNG or a PDF is. There is such thing as a .txt file. My sense is that many people have not seen a .txt file ever in their entire life at this point in time. It's just a little bit too easy to send things around as PDF now, so I think a lot of notes and things become PDFs. I've never seen a .text file attached to an email outside of a tech discipline, right? So I work for a university and I get a lot of PDF attachments attached to emails, and to me this is an odd way to transmit text, but it seems very familiar to people that were used with working with pieces of physical paper their entire life, and now when they want to send someone a piece of physical paper, they attach a PDF to an email. And this makes sense. To me, it does not make sense, because to me, I was trying to transmit text to someone, and the way I transmit text is with a .txt file, right? These are small, lightweight files. Why does it matter they're small and lightweight? Well, we might be moving them across the internet, and we might be moving them across the internet many times, so we care that they're little. And another benefit of a .text file versus a PDF file, you've probably opened a PDF file before and seen a typo in it and wanted to fix it, and that has been impossible, right? It's very, very difficult to edit PDF files. It is very, very easy to edit text files, and so because we're going to be writing scripts and we might be making mistakes and we might want to change them, we are going to work with textual data. The .py file specifically can save code that we type in, and it can be used with Python. So let's go through that example. Okay. I'm begging. I am pleading. I am saying give it a shot. You are not going to want to use NeoVim, and I'm going to want you to use NeoVim. Please try NeoVim. It is, when I designed this class, I designed what I think is an appropriate amount of content for you to take the additional time to learn NeoVim instead of using the editor you're familiar with. There is less content in this course so that you can use NeoVim to do the content of the course, right? And that is also true of the crypto class for different reasons, right? So I'm appealing to you to use NeoVim or Vim or Emacs or Helix or any of these other ones. I'm recommending NeoVim, right? So how do you get NeoVim? Well, it was quite easy for me on Linux, and it's a little bit harder on the other operating systems. So we're going to go over to neovim.io. You can click Install Now. Now, when I click Install Now, I'm going to see something very different than what you see because I'm on Linux, right? But I think if you come here and you're on Windows, you can just get the latest stable release on Windows, and you can just click that button. And let's see, that goes to a .msi file, which is a Microsoft installer file, and you can install that way. I also have WinGit installed on my Windows device, so you can use WinGit install NeoVim if you have that, or anything else. So there's a variety of ways for you to get access to NeoVim here, and they're all described here. The way I got NeoVim, and I will show this to you so you can see it, I just typed in a command line command, and that's one of the niceties, that's one of the nice things you can do on Linux. You can also do it on Windows once you set it up on Windows, right? But it might not just work right out of the box, as it were. So that's how I get NeoVim. Depending on how you're living your life. You can also download Vim or gvim, and so there's also Microsoft EXEs here, and these will also work pretty much just as well. So if you get stuck on NeoVim, this one I think comes with a built-in command line, so you can get an installer here. There it is. Do you need a minute, or do you need help on any of that stuff?
No, I did download it.
You got it? Okay, good deal.
I installed it.
Very good. Here's the Windows install. I didn't use the Linux tars, I used the APTs. I will actually edit that to say use your package manager. Okay, so you can install it from download. Okay. Then I open terminal the exact same way I did when I wanted to use Python. I'm going to close my terminal so I can open it again. Okay. So I'm going to open terminal. Terminal. Ta-da. Okay. This is the Mac OS terminal. This is the Windows terminal. This one's PowerShell. I'm returning to the terminal so I can type at the prompt. We recall the prompt. My prompt is this $, and then I have a flashing cursor. Okay. I'm going to run NeoVim by typing nvim and then pressing enter. Okay. So I'm typing nvim and I'm pressing enter. Okay. Then I am going to see something that looks a lot like this. It says help, check health, Q, help, help, check health, Q, help. For emphasis, I'm going to highlight, I'm going to highlight this line. One of the things that often happens to people when they first use Vim for the first time is they realize after a minute they want to run Python again. And so they're looking at what they perceive as a text editor or the command line, and they know that when you type Python in the command line, Python pops up. So they start typing, they type Python, right? And perhaps what happens is not what they would expect, right? And then they panic and they don't know what to do, right? So one thing you can always do, you can always just close the terminal, right? You can just close this. It'll tell you Vim is running, no problem. I'm going to open the terminal again. I'm going to type nvim, and now I'm going to say, I didn't mean to open nvim. I meant to open Python, right? And I get savings n again because I typed the same keys, so the same behavior happened, right? What you can do is you can I typed regular colon, and then I typed Q. And that gets you back to the command line? Okay. In this case, it's blocking me from leaving because it wants me to save my work. And I think that's okay. All right. It stopped me. So I will do Q. And then you can just add an exclamation point, and this lets you leave. So when you say, I quit, that's more forceful than saying, I quit, right? So that's how you can get out of NeoVim. Okay? So there's a bunch of famous jokes on the internet that you can tell if someone is a real programmer by opening Vim on their computer and seeing if they can successfully quit out of it. And it's it is non-trivial, right? You have to realize you have to press escape. You have to realize that the semicolon Q is showing up at the bottom of your screen, right? It is a little bit different than what you're doing, but it is objectively easy. Like, there's nothing hard about doing any of these things. And you can just Google how to exit Vim, and it's right here, right? It comes up. It's very easy to figure out the answer to these problems, right? But that barrier is still quite a bit for someone that's used to Microsoft Office Word, where you go click the X in the corner, right? And perhaps clicking that X in the corner seems more reasonable to some people. So what we've sort of been exposed to here is the idea of modes. Not all of the keys you press in Vim cause text to show up in a file. Some of them change what mode you are in, and so we're going to introduce modes. Okay. By default, typed characters will not appear in the document. You don't have to, just take my word for it. I type nvim. I'm gonna press a U. Okay, nothing happened. I'm gonna press a Y. Okay, nothing happened. Let's press an M. Nothing happened. Now, some of the keys I press do cause things to happen. Over here, you see I recommend the first thing is we're starting in command mode. So the keys we're pressing correspond to commands. I happen to be selecting keys that don't correspond to any command. So now I'm going to press a key that does correspond to a command. We're going to press the I key, which is going to change me from being in command mode to being in insert mode. So I press the I, and now I'm in insert mode. Okay, now that I'm in insert mode, many of the keys do what I would expect. So I can type, for example, hello, my name is Calvin, and that text shows up as expected, right? So how do I tell that I'm in insert mode? Well, we see that I have insert at the bottom of my screen here, right? I don't actually want hello, my name is Calvin, so I'm now going to get to do many of the same things that I do in another text editor. I'm going to get to press backspace, get rid of that text, and now I'm going to write my piecewise function. I'm going to write def f of x equals if x less than 4, what was it? It was return 9 times x squared plus 5. And I'm just typing backspace and tab, and all of the keys are working the way I'd expect. If x, nope, it's 4 less than or equal to x less than or equal to 8. Return 9. I pressed enter and it auto-indented, right? Like many modern IDEs. I'm going to do backspace to go back to a higher level of abstraction. If x is greater than 8, I'm going to return 2 minus x. Okay. All right. So I typed in my piecewise function. I called it f. Now, I think I can click. You can't always click in Vim depending on how you set it up, so I'm just going to navigate with my arrow keys. And I said I was going to call this piecewise, so I'm going to change it to piecewise. Right. Okay. Navigate with the arrow keys, or depending on the system, mouse. We copy-pasted in the piecewise function. Okay, here's piecewise. I think I wrote the same thing. I wrote ifs instead of elifs. I don't think that matters. The reason it doesn't matter in this case is you can never both be less than 4 and more than 4, so it already doesn't matter if I say else, right? So I can do some deletes. Okay. It's very annoying. Okay. You can copy paste. I can paste here. I didn't really want to do that, so I'll just do a bunch of backspaces real quick. Okay. All right. I'm showing line numbers here. I don't have line numbers up here. We'll get to that later. But I mostly have line numbers here to denote that I'm in files, right?
It's PY file. It's Python file, that's all.
What was that? Sorry.
It's a Python file, maybe.
Yes, this is a Python file. Excuse me. Okay. So, having written some text, we now need to save it to a file. And I'm going to save it to a file by changing mode, right? So, one of the things that scares people a lot about Vim is there's nowhere you can say file save as, right? Not to worry. Instead of clicking on something at the top of my screen, I press a key on my keyboard. Why is it nice to press a key on my keyboard? Well, it means if Microsoft decides to change the layout of the menus in 5 years, I don't have to go find it. I can always just press escape. Escape is always going to be in the same place on my keyboard. Now, someone might sell me a new keyboard where escape is in a different place, right? But I can just keep my old keyboard, right? So I pressed escape, and we notice that the insert goes away, okay? The cursor will move to the bottom of the terminal where insert was, right? Okay, so this stopped flashing pointedly, right? And so now we can type down here. Remember to press escape. If you don't press escape, none of this stuff will work. And I'm going to demonstrate that by I pressed escape, and now I'm going to press I again. And now I can insert things again. Okay, and then I'm going to press escape. I pressed escape and I'm going to start typing, and what am I going to type? I'm going to type T, and T doesn't do anything. I'm going to type L, and L doesn't do anything. These keys don't do anything because I'm not currently in typing mode. I'm not currently in insert mode. Okay, so now I'm going to issue some commands, and the first command I'm going to issue is write, which I start with a colon to denote that it is a command. Then I type W to denote the write command, and I'm going to save this as piecewise.py, pw.py, that's what I call it. When I'm done with that, I'm going to press enter. Now, on my screen, there's a little thing here that says no name. That went away. This file currently had no name, and now it does. I have now named this file. I've written it. I have written 107 bytes to somewhere, right? So I've created a new file. Now that it's a .py file, it has the helpful syntax highlighting as well, right? So piecewise is now blue. And that's nice. All of the X's are the same color. All of the 4s are the same color, right? So I successfully wrote to a file. Now I am going to save and quit. The way I like to save and quit is escape. Oops, I didn't click into the terminal. Escape, colon, X. X for exit, but it saves while you exit as well. And so that's why it's different than Q, which is just quit without saving. So I really recommend using X. I use W and X a lot. So I'm going to exit this, and it looks like maybe nothing happened, right? All I see is that those MVIMs are there, right? You will return to the command line you started with, likely without incident, but there will now be a new file you can use. A new file I can use. Now, I haven't seen the file yet, but I can do, if you're more familiar with Windows, I think I can look for files, right? Files. Oh, there's pw.py. I can perhaps open this. I can open it with a text editor. You see I have Vim and NeoVim because of who I am as a person, and I don't have PyCharm. Oh, there it is. That's the file I wrote, right? So it behaves the way you'd expect a file to behave, but we're able to deal with it all at the command line without using anything that someone's going to charge us money for in a few years, right? Okay, so we have the new file. And from here, we can get into a little bit of scripting. Okay, so I think this is what you would expect the terminal to look like. Yours probably looks a little bit like this because you were on Windows. Mine looks a little bit like this because I was on Linux, and so on. Okay, so I'm going to just introduce a few terminal commands, not too many here, but the one I'm going to introduce right now is ls, which I think of as standing for list. And what it's going to do is it's going to list my local files, and we'll see that pw.py is helpfully listed there. Okay. I can just ask to list things named pw.py, and I see that I have that file. You might see different things on Windows and Mac OS. I think on Windows you're going to get a lot more text. There's going to be many more things there. It might tell you the size of the file, for example. Does ls work on your Windows device? Okay. Does dir work? Okay. You are in command.exe instead of PowerShell, and I'll try and remember that when I'm talking to you. But you should also remember that I said that to you if you Google and ask for help later. You are in command.exe, not PowerShell, and that's fine. Both of them are equally bad. Okay. So we're going to lspw.py, okay? And you'll see different things on Windows and Mac. Here's what it looked like for me in Windows PowerShell. And you'll see I have the PS here. That denotes it's Windows PowerShell, and that's why ls works. You can probably just type ps in command.exe, and it might open PowerShell. And then here's what it looks like on Mac, and it looks the same on Mac as it does on Linux. Okay. But anyways, make sure you have a pw.py file. You should either see it here. I don't remember what dir looks like, but I think it looks an awful lot like this. So, let's go over a few ways to use a .py file. And I think the most common is import. So we're going to begin, go to the command line and start Python. You'll notice there's an I at the end of Python. That's a typo. That's because I made these slides in Vim, so there was a stray I there. I probably pressed I by accident twice and didn't notice it. So we're going to go ahead and invoke Python. And there I have Python. Okay? That's the next thing I'm going to do. I'm going to take note of the prompt. I'm going to notice that if I type nvim here, it doesn't work, and I'm going to notice if I type Python here, it doesn't work, and I'm going to notice if I type ls here, it doesn't work. I type ls into Python a lot, because I type ls all the time while I'm navigating the file system, and I keep meaning to see I can't do that here, right? But I'm not currently in the terminal, I'm currently in Python, right? So I got to remember that. Now, we are going to introduce the import keyword. Import is like return. You remember return, where we typed return and followed it by a space. You remember we typed def and followed it by a space. You remember we typed if and followed it by a space. Remember we typed for and followed it by a space. Import's the same way. The difference is with import, we're going to give the name of a file, and that file is going to be pw.py, but we're going to leave off the file extension. Having that .py there means that Python can see the file, right? So I'm going to type import pw. And I'm not going to see anything. This is the same as having those lines that don't return anything. Remember this, sometimes we just don't see anything, right? And we don't see anything with an import. That's good that we don't see an error, because we would see something bad if it didn't work. So we did successfully import pw, our piecewise function. So this is what it should look like. This is good, okay? Let's take a look at what pw is. It is of type module. Modules aren't too exciting. It basically corresponds to a file, right? If we look at it here, it is also a module. And hey, that's the name of my file. And it's my file. It lives in Calvin. Oh, that's fun, right? And so this is the full name of my file, the full legal name, rather than just its given name up here, right? This will probably look different to you on different devices. So here I'm in home Calvin PW because I'm on Linux. Over here it's a C users Calvin PW because I was on Windows. Right. Okay. Now, there's a few ways to, let's see, I want to zoom this in. Okay. There's a few ways to use functions from inside the module. First thing we notice, this is a module. Within this module, there is something called piecewise. Piecewise is a function, and functions can be applied to arguments. So I can compute piecewise of 1, 4, 5, 8, and 11, and get the expected 14,999, negative 9, right? So the code I wrote in that .py file, I'm able to use from inside Python. Now I can't see it. The only thing it tells me is this is its address, which is not a very easy address to understand, right? But I can use that file. So I've written my .py file. I use its name, dot, and the name of functions inside the file to refer to it. And this is really useful in case there's something else called piecewise, and in fact there are other things called piecewise in Python, so it's nice that it has this little prefix on it so we know which piecewise we're talking about. Okay. We can also rename these functions using single equals assignments. I call it piecewise here. I'm just going to call it f. And now I just have a little function I can work with quite easily. Right. I can also use from. So I have a file called pw. I can say from pw import piecewise. Then I can use piecewise directly. this is probably the right way to do things. You can also give things names. Let's see, is F already used? I'm going to say from piecewise import piecewise adds G, because I already used F. And then I can do G of 8. Or nope, I was going to do, the whole reason I called it G was so that I could demonstrate it. There it is, G of 8. You may know the famous hit song from the early aughts, Like a G6 by Far East Movement. I don't know. Anyways, that's like a G6, right? So this is the common way to import things. Now, I spent a great deal of time making sure that you could safely get out of Vim, and I haven't told you how to get out of Python. There's 3 ways. You can type exit. You can type quit. And you can type Control-Z. I think on some systems Control-C might work. Not all of them. But hold down Control, press C. That gets me out. I think I was using someone else's device and I could type exit without using parens. Oh, and apparently you can use Control-D. So,
Control-D?
yeah, that's what it says. See? Look at that. Control-D. I know that. So these are all different ways to get out of Python. I usually do exit. There also, can you do... Some programming languages just do Q. I'm trying to remember which ones. Do I have R? Yeah, okay. So, make sure you can get it out of Python. The thing you really want to be able to do is get into NeoVim. I'm going to use E to edit password.py. We're going to change, so what am I going to change? I'm going to return 7. I'm going to type I, backspace, 7. I'm going to save and exit, Python, import, pw, then I'm going to say pw.piecewise of 6, and this is now going to be 7 instead of 9. Okay, I'm done. D. Okay, so I'm going to do NeoVim. If you provide NeoVim with the name of a file, it just opens that file by itself. Okay, we're going to change this to 12. I'm going to exit, Python, import pw, pw.piecewise, 5.5, and it's 12. So that's sort of the going back and forth flow that I use to write and edit my files. I do find it quite a bit faster and easier to do all of this in the command line than outside of it, but you can do one other thing. I want a second terminal. Can I split that? Detach? Oh no. What's it doing? Oh, I crashed it. Okay, that's fine. Oh, my terminal passed away. Okay. Oftentimes I will open 2 terminals. Can I open 2 of them this way? Let's detach. There we go. Wow, that is so annoying. Okay, it keeps crashing when I'm doing some inputs to it. Wow, and oh, my computer's crashing. Okay, that's fine. Let's get terminal back open. I get another one. I'm going to detach. Okay, I cannot detach terminals on this computer. I often have 2 terminal windows open, one with NeoVim, one with Python. For some reason, I can't demonstrate that right now, which is a little bit surprising to me. Oh, maybe if I do new window? Oh, it's totally fine when I do that. I guess that's just the way you're supposed to do it. Okay, so this one goes over here. This one goes over there. Python, nvim pw.py. Okay, what am I going to do? We're going to change this to, what's your favorite number? 22, very good, good choice. I'm going to write just W. Import PW, pw.piecewise, 6.6, and that gives us 22. Now, one thing I do want to point out when you're using this method, if I come over here and change this again to, my favorite number is also 22 because of the Taylor Swift song, so I'll do my next favorite number, which is 93. If I write this, if I come back over here and I import PW, this won't have changed. I have to close and reopen Python in order to get the 93.
Oh, you have to close Python?
Yeah. So now I get the 93. So one of the reasons I think to not have just the two windows open is because I pretty much want to close and restart Python every time I edit this file. So to me, it sort of never made sense to use both. Okay. All right, let's use the terminal. I stepped through this process with you. Were you able to do all of these steps?
Yeah.
Okay. Here's the other way to do things. You can write yourself a little script file. Let's write ourselves a little script file. Now, I had some x's, which equals, what was it? -1, 4, 5, 8, 11?
11.
I think that's right. I'm going to put some spaces in here because I feel like I'm supposed to. Okay. 4x in x's piecewise x. I'm going to save and exit. And actually I'll demonstrate something before we do this. Let's see, Python import pw. Okay, so I'm still able to use piecewise of 9. Okay, very good. I'm supposed to do Control D, not Control Z. I didn't know that. I'm sorry, Python. Okay, so let's run a script file. We're going to start with a little hello world example. So let's go ahead and do that. I'm going to say nvim hi.py. I'm going to not start typing. I'm not going to start typing print, because this is what I get if I type print hello terminal. I get that. That's probably not what you want, right? And that's because the I from this print is showing up. That's when I start typing, right? So instead of that, I'm going to enter insert mode and I'm going to type print hello terminal. Okay. I am going to press escape, I'm going to press colon, and I'm going to press X, and that is going to save and exit. Okay. I am going to type ls star.py, or I'm going to type dir star.py, and that's going to show me my py files. Okay. I'm going to save and exit via escape colon X, then I'm going to run the Python script. How am I going to do that? I'm going to type Python, I'm going to type Python 3, I'm going to type hi.py, and it is going to run the code in the Python file. This is all very exciting, right? Now, there's one kind of interesting thing going on here. Let's take a look at nvim pw.py. There's code in here that should be running. If I copy-pasted this into Python, I'd see some stuff, right? So when I run Python pw.py, why don't I see that stuff? Well, I'm only seeing what is printed. This has a print statement in it, so I only see things at the terminal if I print them in Python. Those numbers are still calculated. They're still used. Python calculates those numbers shows them to itself, and then goes about its business, right? It never tells me about the numbers, which is upsetting to me because I wanted to know what those numbers were, right? I worked very hard for those numbers. It seems unfair that Python gets to know them, and I do not. So it runs the code as if it was entered in, but it only provides the expected print statements, okay? So I'm going to update pw.py with the following print statement. I'm going to print the element of x's, and then I'm also going to print the function of x's, okay? So let's go ahead and do that. What do I have open here? I have too many tabs open in my brain, I think. Let's close that terminal. Let's nvim pw.py. I'm just going to add a print statement here. I navigated down with arrows. I pressed I type print, colon. I press the arrow over. I do another. I said colon. I meant parenthesis. So that's, I have closing, opening parentheses. All my parentheses are lined up. I press escape, colon, X. That saves and exits. And now I'm going to Python, pw.py, and I'm going to see the values. Let's edit this over and get it a little bit nicer. I'm going to press the up arrow twice to get back to nvim. This 93 was supposed to be a 9, I think. So I will press I for insert, and then I will backspace. And I wanted to print not just the piecewise value, but also the x value. So I'm going to create a list. I'm going to use a boxy bracket, x, comma, space, piecewise x. I'm going to close that boxy bracket because I want to print the list, and then I'm going to have a regular parenthesis at the end. Okay? I'm going to press escape, colon, x to save and quit. Then I'm going to either type Python pw.py, or I can press the up arrow until I see Python pw.py. And that gives me the values of the piecewise function, and that's how I can do Python scripting using NeoVim. Okay? This is the expected output, and you'll see that I got the exact same thing. Right. Sometimes we want to do interactive scripting. And I think it probably makes the most sense to get into interactive scripting after we find some food. So let's go try and find the cafeteria and see if we can eat anything. We are at a nice, easy stopping place. We're at 50 of 75, so that should be easy to remember. I'm going to turn off the stream. Let's go find some lunch. Stop stream.